Welcome everybody in the lecture hall. Welcome everybody on Zoom. Welcome everybody watching us from the future. So today I will finish this part on data definition with SQL. So that's a practical part where we basically are looking at how we define tables, how we specify the columns of the tables, the types of each column of the table. And then I will show you a few more features of what we can do. I'll show you, well, I already started showing you how you populate the tables, how you basically put data in there. And then probably in the second hour, we will move on to yet another mathematical part where we look at the beautiful relational algebra that works on these sets of maps that we've been studying. So before we do that, I have a question for you. Which one of the following comments, these are 4 comments in SQL, is not the DDL comment? Create table, alter table, insert into, or drop table. Alter table, we haven't looked at it yet. We'll show it to you, but I think you probably guess what it's actually. The others, we looked at last week. What does DDL mean? Data definition language. DML? Data manipulation language. Exactly. So one of these is a DML. So we have a majority, and it turns out that it is correct. It is indeed when you insert data that you're manipulating the table, because you're actually modifying the content of the table. DDL has to do with the schema of the table. It's the columns, the types, the constraints, and so on. As soon as you touch either read or write to the contents of the table, the actual data, then this is DML. Right? So the names of the columns, the types of the columns, this is not the actual data. This is called metadata. Yes. Meta means about, right? About the column. So let me go back to the slides.
Excuse me, I think there's a problem with the mic.
Is there a problem with the mic? Or sorry, I didn't. Oh, I am using the computer mic for the Zoom audio. Let me check that. Yes, you were right. Is it better now?
Maybe try moving around it, because when you're facing the computer, we hear you the same. It was when you were walking up the...
But normally you can hear me now, right?
It's perfect, yeah.
Okay, perfect. Yeah, no, it's important because then it gets recorded and then I'm going to speak and then nobody will actually understand what I'm saying on the recording, especially since I'm walking around in the lecture hall. Yeah, thank you very much for that. All right, so let's continue. So this is where we left. We basically inserted data into the table, but this time we inserted partial data because as you can see here, there's 6 columns in the table, but we only inserted data in 4 columns. So I specified the names of the columns right after the table names, right? Person, first name, and so on. And then after values, the actual data, but I only specified data for 4 of the 6 columns. So what happens in that, in this case, you basically pad everything else with nulls. Right? Everything where you don't have, so middle initial last name is not in there, and you put a null in there. So let me take a step back and tell you what null is all about. Null can be seen in many different ways, actually. It's kind of a special value or the absence of value. So let me tell you a little bit about that. So the idea is that it can mean many things. It can be that you don't know the data. It can be that the data is not applicable because Spock doesn't have any middle initial or last name, for example. It could be that you don't have access to it, that it's a secret, that you don't know it yet, and so on, right? So it can have a lot of interpretations. Now, how does it map with what I explained about the relational model? Remember, a table is a set of maps, and we require that the maps all have the same attributes, the same support. That's the relational integrity. We require that the domains are consistent across columns, right? The values have to be in the same domain in the same column. That's domain integrity. And atomic integrity means that it's only atomic values. So the domains would all be atomic. So now null is a bit special. And in fact, there are two ways to look at it. So let me go through each one of the two ways to make it clear. The first way to interpret null is that it's a special value that you add to the domain. So for example, if you say here that you have a first name that is varchar is string, basically it's a string. So first name is a string, middle initial is a string, last name is a string. So basically, it's a string or null. So the set of strings is extended with one more value that is the null, and then that's fine. You just assign in this map, middle initial is assigned to null, right? So the domain is string plus null. In that case, you have relational integrity, right? Because null is a value. It belongs to the domain because we extended the domain with null. So that's fine. Who agrees with me? Right? It's just an extra value. There is another way to proceed, which is to consider that null is the absence of value. It means that in the third map here with Spock, that's a map, right? A record is a map. Middle initial would not be mapped to anything. That's what null means. And last name would not be mapped to anything. It means that the support of the third record is only first name, birth date, scientist, passport scan, but middle initial and last name are not in the support. In that case, do we have relational integrity? Who thinks we do? Who thinks we do not? Relational integrity means the support of all the records is the same, right? So you agree the support of the first two records, that would be the 6 columns, but the support of the third record, if we assume that null is the absence of value, that it means it's not mapped anywhere, then do you agree that the third record has a different support? Because that support only has 4 columns. Who agrees? Right? So then we break relational integrity here if we interpret the null like that, right? And so that's kind of, there's the two ways of looking at it. Either you consider that we don't breach relational integrity and null is a value like any other, and so it's still in the support. Or you consider that null is the absence of value. What it means concretely is that we have some margin of tolerance for a breach of relational integrity. It's okay to break relational integrity with a few missing values here and there. That's the second way of looking at it. Right? For whom does that make sense? Okay, so two ways to look at the nulls, extra value or absence of value. Okay, all right. So you see, we are, with the second interpretation, we are breaching relational integrity, and that's okay. You know, the Earth is not exploding. So this is all working. And you'll see in big data for engineers, we will break even more rules than that, much beyond just that. Okay, so this is about the null. Now, you have some control whether or not you accept the nulls. And that is done right here inside the create table statement. So you have the name of the column, you have the type of the column, varchar 30, and then you can add not null. The case is not important, but typically people do it uppercase, right? So not null. In that case, you forbid any null, right? So with the second interpretation, it's a way to enforce relational integrity. If you put not null everywhere and you consider that null would have been the absence of value, then you enforce relational integrity, all right? So you can put null or not null, but of course, if you put null, that's the default anyway. So if you want to be explicit, you can put null if you want to allow it, but even if you don't, it's allowed by default, right? So that's it. So you could actually fill it like this. So in that case, for example, if we want to have a schema for this, where middle initial and last name can be null, then we would say null, null for these two and not null for the others. And what's really nice is that PostgreSQL will enforce this. If you ever attempt to insert data with nulls in the columns where it says not null in the schema, it will not let you do it. Error, right? Immediately you get an error. So it's a good practice when you design a schema to try to be as specific as possible. And if you know that you want the values to be present and you don't accept a null, then you put not null everywhere you can to enforce it. You can still change it later. If you realize you do need a null, you can still change it with alter table that I showed. Okay. So here's another comment. It's an updating comment. What if we want to modify a value? Imagine that we want to modify the last name from Crusher to Picard. So we say update persons, that's the name of the table. We set the last name to Picard, where the last name is Crusher. So where is the last name Crusher? It's here. So we set it to Picard, right? So this where, we'll come back to it actually in 2 weeks when we actually query data. It's actually picking this line here, this record, because this is the one where last name is Crusher in the map, right? And so we set last name to Picard and modify it. This is actually modifying the table, right? So that's an update statement. That's the ML, right? Because we modify. Yes? Then it's going to update them all, right? Most of the systems actually even provide you a choice. You have a way to say update just one, or you have a way to say update all of them. So there's many that let you do it. But I think in that case, it's going to modify them all if there's multiple, right? Okay. You can also delete a record. What if you want to remove Spock? Then you just say delete from persons where first name equals Spock, and that removes the record, right? Now you have only 2 records left in the table. Okay, so this is again DML, right? Data manipulation, because here you're touching the data. All right. Now here's one more thing you can do. So I already told you can have null or not null. What you can also do is supply a default value. So if you don't have any value, then you put that value. This is useful in the case that you insert partial data. If you have 6 columns, but you only insert data in 4, and if you have a default here, instead of putting a null, it's going to put the default data. So you see here, it's the same insert into that we had before. The only difference is that I defined the schema of my table with default n for the middle initial and default none for the last name. Now it's not going to put nulls here, otherwise it would have been nulls. But since there is a default, it automatically fills it with n and none. Yes?
If I specify itself that I want to null, will it put null or the
No, I think if you specify the value, it's going to pick the value you specify. I don't know, I can't remember to what extent you are allowed to use null inside a SQL query. I think you can, but some systems do not allow you to explicitly put a null in the query. But if you put a value in there, it takes it over, right? So whatever value you put in there, it's going to be taken over. That's a good test, actually, that as an exercise for next week to try it out. You can do it quickly in a Jupyter notebook. You can just create a schema, insert into it, and see what happens, and either confirm or deny what I've just said. Okay. All right. So the default is really if you don't specify, then it's going to use the default. Okay. Now I'm coming to alter table. So alter table is for modifying a table. So creating a table, dropping a table that you know how to do, right? Create table, drop table. So let's now alter the table. So altering a table is when you change your mind, the table is already there, might also have data, and you want to change it. You want to change the schema of the table. For example, you could want to add a column. So this flag Boolean here, after the add column, is the same syntax that you would have here for each line, right? So so that's the column name, then the type, then you could have default null or whatever you want. That's exactly the same syntax. You just put it after add column, but of course for just one column this time, right? And that's just going to extend the table, adding this column with that name and with that domain, okay? So that adds a column. You can also use, as I said, the not null constraint. So here I put it lowercase just to show that it's flexible. Uppercase is just would make it easier to parse because that's a keyword, right? So here we even say not only not null, but even default true. So not only do we disallow the null, we also say if the value is missing, then just put a true in there. Okay, and we call it flag 2. we can rename the columns too. So if you want to call flag F instead of flag, then you can use alter table with rename column flag to F. Okay? So you see, you can modify a lot of things on the fly. You can even drop a column, right? So here, you're just dropping column F, and that's removing it, right? Now you can also rename the table itself, right? If you want to change the name of the table, that's also alter table, but then you just say rename to table. Okay. Now you might be wondering what happens if there's already data in the table, right? And you want to modify the table. So drop column is just going to remove it. And if you want to insert a column, for example, here, imagine there's already data in there. What this is going to do is just put true everywhere in that column, because that's the default value. So it's going to use the default value everywhere in that new column because you don't have any data yet. If you didn't have default true and it was allowing for null, it would just populate the whole thing with nulls, right? And if I'm correct, if you try to add a column and you say not null and there is not a default, it should complain about it because it wouldn't know what to put in there. And there has to be something, either a null or something else. Okay? Who is with me? Okay, so now you know how to alter the table. You can add a column, remove a column, and for the column, you can specify here with exactly the same syntax as in create table. That's exactly the same syntax as here, basically. Okay, so now let me look into the constraints. So not null is actually one of them that I showed you, but there's two more. There's check and there's unique. And there's also primary key that I'll show you as well. So this we've already covered. That's called the constraint. It's called the constraints, and more precisely, it is called a column constraint or an attribute constraint because it applies to a column. Here, this not null applies to column name, right? We'll see that you can also have table constraints. I'll come back later. So this is a column constraint, and here it restricts what is in name. It doesn't allow any nulls, right? Okay, but that I already told you, so this is something that I'm just repeating here, right? So for example, what you see on the left here, name null, that cannot happen. So it will not even let you do it. You would get an error if you ever try to do that because of this. But here it would allow you to have a null in there. Okay, here's another one that you can put here. It's a different kind of constraint. This constraint, it's a column constraint or an attribute constraint. It says the name cannot be Spock. This lower than greater than means different. An alternative to it is exclamation mark equals that you also find sometimes, right? It just means name cannot be Spock. What does it mean? If you ever try to insert a value Spock in there or to update a value to Spock, it will throw an error and not let you do it, right? Of course, in check, you can put whatever you want in there. There's a general expression, let's say a la carte, right? You have a list of everything you can have. You can have comparisons, you can have arithmetics, logic, and so on. So you can basically combine your own formula here, put it inside the check, and it will enforce it every time. It will always evaluate whatever you put after check and make sure that it is always true. So this is a constraint. That constraint comes on top of relational integrity, domain integrity, and atomic integrity. That is yet another constraint that comes on top of that, right? That is, you decide basically what the constraint is. Okay? So that is a column constraint. Now we have yet another constraint that's called unique. Unique makes sure that you cannot have twice the same value in the column. Example, you have a table of people, social security number. You cannot have two people with the same social security number. So you can just say, I have a number, unique, right? It will make sure that it will not repeat. If you try to insert a second time the same number, it will throw an error and not let you do it, okay? So in that case, we're saying that the name must be unique and the AHFAO must be unique, right? Now, something that one might wonder is what is really unique here? Is it every name is unique and every AHFAO is unique, or is it the combination of the two that is unique? Well, if you write it like this, then every name is unique and every AHFAO is unique. If what you want is for the pairs to be unique, then you wouldn't put it like this. Instead, you would put it, oh, I didn't put it. You would basically add a new line here saying unique name AHFAO, right? And that would be called a table constraint. If you say unique name AHFAO, then it would allow name duplicates and AHFAO duplicates, but it wouldn't allow duplicates of the two combined. For whom is that clear? So that is called the table constraint. Okay. And the same goes for check. You also can use check as a table constraint if you add a comma here and add a new line with check and then a formula that might use multiple columns. This one uses just one column, but you can say check with multiple columns, and that will be called the table constraint. That might involve checking that two columns are equal or two columns are not equal, for example, and so on. Okay. All right. So this, for example, would be forbidden because we say name unique. So it will not let you do that. Now, a question that usually comes, this last year it came, is what about nulls? When we say unique, can we have multiple times the value null, right? And so by default, if you just say unique, then it's fine to have multiple nulls. What must be unique is the values when they are not null. But nulls, you can have as many as you want. If you do not like that, there is a special command that you can add after unique. I think that it's called unique null not distinct. And if you say unique null not distinct, then you are also making sure that the nulls are unique. There's at most one null, right? You have the documentation open, so you can confirm, but it's unique null not distinct, I think is called. And if you say unique null distinct, that's the default, and then it basically assumes that different nulls are not equal, right? So you allow for more than one. For whom is that clear? All right, very good. Do we have a question?
Can student Boolean column be unique as well? I think it's fine.
Yes, it can. What would it imply then? What happens if I make student Boolean unique? Yes? Yes, that would be a small table. There's one row with true, one row with false. Maybe I get plenty of more rows, but they will all be null, basically. But if on top of it, I use a student Boolean unique, it's like a tongue twister, student Boolean unique, null, not distinct, then I will have at most 3 rows, true, false, and null. And that's it. If I try to add a 4th row, then there would be duplicates, it would be refused, right? So the answer is yes, you can do it. However, that will restrict the size of your tables because there are not so many Booleans out there. Did it answer your question? Yes, awesome. All right, it's good. It makes you think. Yes?
You say that a single value must be unique. So for example, if you have a table with administrator, and only one person can be administrator. So you can have one true here and everything else should be false.
Ah, that's a good question. So basically, the idea is, can you say just a specific value is unique and the ones are not? I actually don't know. We could check in the documentation if there's anything, if maybe with a check constraints, there's any way to build a formula that does that. If I think out loud, the way you would do it with a SQL query is with a group by, right? You would say a select group by, we'll see that in 2 weeks, right? But select blah, blah, blah group by, and then check the count that it would be exactly 1. And maybe there is some way to nest that query somewhere in order to enforce that it's always returning some number. I could imagine maybe, but that will already be advanced if we do that, all right? But yeah, the answer is I don't know. It could be that there is a way. Okay. No other questions? Okay, so let's move on to primary keys. So primary keys, I briefly mentioned it in the first week, is when you want to identify the records, which is something very common in tables. You want something that identifies a person, so you could use the social security number, AHFAO. You could use something, for example, that identifies a course unit at ETH. And you know that there is this code that you see in the course catalog with all kinds of digits that identify a course. You can identify countries. Cantons in Switzerland have these 2 letters. So you basically have identifiers for the records. These are called primary keys. So in a table of persons, you could use the AHFA number, the social security number. That is a number made of now 13 digits, used to be 11, now it's 13. And so you want to say that several things, in fact. The first thing you want to say is it should be unique, right? You cannot have 2 persons with the same AHFA. The second thing you want to enforce is there cannot be any nulls in there. You cannot have a person that doesn't have a social security number, right? If you arrive in Switzerland and start working, you will be assigned a social security number. So a primary key means it's unique, it's not null, it identifies the records. So it can't be null and so on, and it must be unique. But then you might tell me, yes, then there's unique, not null, right? We already know how to do it. So indeed, you could say unique, not null, and that does it. That was the answer?
Yeah, I just checked null because null values are treated as distinct entries. So specify nulls not distinct on unique index, just as you just said. So we can treat as not distinct.
Yep. Thank you very much. So that's the unique, null, not distinct.
Yes.
That basically would say that the nulls are also to be unique. Okay, thank you very much for this. So now if you say unique, not null, then you basically did the job. That's already what we want here. But the thing is, it's actually not enough because we also want something else. We also want to add the information that this is what we want to canonically identify a person. We want to say that it's not just that it's unique and not null, it's also that I want this to be the means to identify the records. And that will be clear just in a couple of minutes when I introduce foreign references. So this is why, that's an example here where that works. We also want to reference from somewhere else, maybe from another table. We would like to put a social security number that references that record here, for example, Isaac Newton. So I'm not just telling you how yet, but basically it means that we need a special syntax for it. We cannot just say unique, not null. So we really need to say primary key. So primary key is yet another thing you can put in the schema here. And that really means that it is special. This column is special and identifies the records. One difference is that unique, not null, you can have it on as many columns as you want. You can have multiple columns that are unique, not null. But the primary key, there can be only one. Only one primary key. However, that's what I mean with basically table constraint. So this is a column constraint that is as a table constraint. So the two are equivalent, right? But basically you say primary key AHFAO does the same thing. When I told you earlier, you can also put unique and check, it's exactly like this. You can also put unique and check on their own line at the end, and then you can do it with multiple columns involved, right? So unique with multiple columns, check with a formula with multiple columns. But basically, the goal of doing that is if you have multiple columns that jointly identify a record. Imagine it's hypothetical because, of course, in real life, it's not like that. But imagine that it were the case that people are uniquely identified with a first and a last name. Then you could put primary key first, last. And that is still one primary key, but it's one primary key that is compound. It's composed of multiple columns, right? So you could have people with the same first name or people with the first last name, but you cannot have people with the first and last name in common, right? Again, in real life, that can happen. That's just a hypothetical example. Another example would be with registration plates for cars, right? You would have the canton and the digits, and these together uniquely identify a car, all right? Okay, for whom is that clear? All right, and that thing you see with primary key, you can also do it with unique. You can say unique first last, and that also works. That's unique as a table constraint instead of as a column constraint like here. So column constraint on the same line as the column, table constraints on a separate line at the ends. Okay, awesome. So now let me come to these foreign keys that I told you about. So this is here the primary key. it identifies. Now, what if I have here another table? So it's not the tax report. Let's say I have a table that contains the tax residence of many people. How do I specify it? Well, I need a way to identify people. So for example, I'm going to say that this person here, who has this AHFA number, is a fiscal resident of Switzerland. This person here has a tax resident in Austria, and this person here has a tax residence in the UK, right? So this here is a table that presents the tax residence. But this is not a primary key. The primary key is in this table with the persons, right? A person is identified with the AHFA number, right? And then you might have the name, the address, and so on and so on. So plenty of other columns. So what you want to do here is to just have a link between these two. You want to say that I have my tax residencies, and whenever I put an AHFA in there, it basically references the records with the corresponding AHFA. For whom is that clear? That's called the foreign key when we do that. One important difference is that the primary key is unique. It cannot repeat. You cannot have multiple persons with the same primary key. However, this can be duplicated. You can have multiple times the same AHFA here. That's basically a person who would be considered a tax resident of multiple countries, would appear here with Switzerland, here with the UK, and so on, so multiple times. So it's totally fine for a foreign key to repeat. Then it's going to be multiple times the same person. But here it must be unique because there can be only one person. For whom is that clear? All right, awesome. How do you do that? Well, you do it again using a colon constraint. So when you define this table here with the fiscal residence, you say create table taxes, the usual with the column names and the types. Sorry, there is a typo here. There should be an underscore. There cannot be any space, of course, for obvious reasons. So the name of the column, the type. So after the type, you add references, persons, AHFA. This says that this column here is a foreign key, and that foreign key is linked with the column AHFA in persons. This is exactly what I showed here. This AHFA references persons AHFA. Okay? In fact, when you do this, you can put any column in there, right? Doesn't need to be the primary key, but it has to be a column that is unique, right? So either unique or primary key. But if you do not put anything, you just say the name of the table, this is where it's going to use the primary key. So if you just say references persons and you define the table persons using a primary key here, then it's going to use AHFA for what this column is referencing. Yes?
If you want to reference a foreign primary key that has two values, then you have to reference both values here.
You can also do that. The combination has to be unique then, but that I think I have a slide for that too, right? So for now, I'm only showing if it's one column referencing one column, but you can also have multiple columns referencing multiple columns. That also exists. So here, that's an example of a duplicate, right? So this is the foreign key. It's totally fine to have duplicates. This is the same person that appears once in the persons table, but it's just a fiscal residence of both the UK and the US, right? Now, and this is your question, and we have also a question on Zoom. So let me first address your question, and then we'll come to Zoom. So compound keys. Imagine hypothetically, in some hypothetical world where people are identified with first and last name, we could say, as a table constraint, because again, if it's more than one column, then you cannot put it on the same line as a column, it has to be separate. Then you say foreign key first, last, references persons, but again, you need two columns. You need the same number of columns here and here. Okay, and this is how you would do it. Does it answer your question? Awesome. Then we have the question on Zoom.
So if I have a column that happens to have unique atoms, but was not defined as unique when created, can it be used as a foreign key? I mean, yeah.
I think thinking out loud, what you would need to do in that case is first use alter table to add the unique constraint. you would say alter table, modify column, blah, 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 unique. I assume we can test that then it's going to check that it's unique. And if it has checked that it's unique, then it's adding the constraint saying, yes, that's okay, it's unique. And then it will enforce it in the future. And then you can use it as a foreign key. But I think you will not be able to use it as a foreign key if it's not enforced as unique. It's not enough that it is unique, it has to be enforced as unique, right? Does it make sense? All right. And so here for persons first last, you would need as a table constraint in persons, unique first last as a constraint, or primary key first last, right? Either unique or primary key. All right. Everybody with me? Okay, let's go further. What about nulls? The primary key, no nulls. That I've already said. In primary key, you cannot have any nulls. But in a foreign key, not only can you have duplicates, but on top of it, you can have nulls. That's totally fine, right? You could have here a course. We don't know who's teaching it, but it's about formulas, maybe because the person is not assigned yet. That's totally fine. You basically just have a foreign key that is not linked to anything, null, null, right? Not tied to anything, and that is okay. Now, let's think a little bit, because what we've done here is important. We have taken multiple tables and we've attached them together, right? A foreign key in one table that is attached to the primary key in another table. So there is a link now between the tables. So now imagine that we have these tables with fiscal residence that references the people, and then somebody wants to delete from that table to delete somebody. What if that somebody is referenced somewhere, right? Because part of the foreign key semantics is that it has to check for existence, right? You would not be allowed to put anything in there that wouldn't exist as a primary key on the other side, right? It has to exist. But what if you delete? So you delete that, but it was referenced from the other table courses, and you delete it. That's going to break your foreign key constraint because Kurt Gödel is supposed to exist in the table. So you will have a problem. And so the question is, what do we do here? And there's multiple strategies for that. So the first strategy would be that if you ever delete a person, then you also delete whatever is referencing it. That's called cascade, like waterfall, right? So you basically would automatically, upon deleting Kurt Gödel from the persons, that also triggers a deletion in courses. Strategy number one. If you want that to happen, then you just say foreign key reference person. So that would be basically as a table constraint at the end. But you add, after the references, you add on delete cascade. And then whenever you delete in the table that has the primary key, that's going to automatically trigger the deletion whenever it's referenced. Strategy number one. Strategy number two is disallowed. If you ever try to delete somebody in here that is referenced somewhere else, you basically get a refusal. PostgreSQL says, no, sorry, cannot delete it because it's used at other places, right? If you want this, then you say on delete restrict, okay? Strategy number three is you set it to null. So if you delete that person and it was referenced, then you just replace it with nulls everywhere it's referenced. We saw that it's allowed to have nulls, right? That's strategy number three. Strategy number four is you set it to the default. So imagine hypothetically that the default for first is Albert and the default for last is Einstein. Then upon deleting Kurt Gödel, that will automatically replace it with the default. Who is with me? So you have four strategies: on delete cascade, on delete restrict, on delete set null, and on delete set default. Four different strategies. And that is really, really nice because imagine all the automatic stuff that happens in there. You're basically saying in advance, when you define the schema of your table, you're already provisioning for the future. You're already saying if any time in the future somebody deletes it there, then you will automatically trigger this and that behavior. this is really, really nice automation, right? That you get out of your database management system. So these are typically the features that a database management system is giving to you, because it's going to make sure that all the unique, the not null, the check, the foreign key, all of that is always respected at any point in time. And if it's not able to make it be respected, it will throw an error at you and prevent you from breaking these rules. So it's very, very convenient to have this. Any questions on Zoom? Everything clear? Everybody with me? Okay. I think it's the last slide of this part, right? So what have we learned then now, and you should do it, you should take the notebooks, the Jupyter notebooks that are given in exercises, try to create tables, try to drop tables, try to alter tables, try to put data in the tables, try to put data partially in the tables, whether it's null, not null, default values, and so on. Try to create unique constraints, try to create not null constraints, try to create check constraints, try to do it as column constraints, try to do it as table constraints, try to create primary keys, try to create foreign keys pointing to primary keys, try to delete records on the primary key side and see what happens, try to change the strategy, play with it, right? This is really something that at the tip of your fingers in a notebook, you can just do it, all right? There's just maybe one thing you need to know, probably given in the exercises, it's how to view a table. Because of course, if you do these things and you want to check if it worked, you need to view a table. And the magic word for viewing a table is select star from the name of the table, right? Who has already seen that somewhere? Right, that's the SQL for it. So it will be provided, I think, in the exercise sheet. Select star, the star character, from persons, and then you see it right in your notebook. It's going to show you the nicely formatted table. Okay, it's pretty cool, right? The sort of things that we can do with these systems, and this is really used all over the world. But I don't know of a single company large enough that would not have a system like that to store their data. All right, so this is what we call a database management system that handles all of that for you. And you notice, by the way, that there is not a single mathematical formula in there. It's just purely tables and tables and tables with rows and columns and a language that resembles English to make it work. Okay, so let's take a break. The timing is perfect, so it's about to be 11. So I'll continue at 15 past 11. Take a good break because there's going to be math now in the second hour about the relational algebra. So see you in a bit.